Dear student, Vanakkam. Let us have the discussion regarding the multiple choice questions in our subject physics. This is not the audio and video like some other audio and video, purely subject based audio and video. Hence, we both need much concentration. So, listen carefully. Let us start from the question number 1. Let me read the question. The equipotential surface of an electric dipole is dash. What about the equipotential surface of an electric dipole? First, we must know what do you mean by dipole. A dipole is a system with two equal charges but opposite charges. Say one is minus q, another one is plus q. The two are separated by a very small distance, 2d. Dipole distance. Example for the electric dipole: water molecule, carbon dioxide molecule, ammonia molecule. This is the electric dipole. What is equipotential surface? It is a surface on which the electric potential is same at all points. Say for example, if this one is a point charge plus q or even minus q, and these are the electric lines of forces, that is electric field acts at a distance r. At this point, due to this charge, what is electric potential? We know V is equal to Q by 4 pi epsilon naught R. Yes, we have thorough knowledge about the electric potential at a point due to a point charge. So, knowing this Q and also R, you can calculate the electric potential. Same way, at the distance R here, at the same distance R here, at the same distance R here, what is the potential? All these potentials are same, equal. Hence, the surface in 3 dimensions, the surface which is a sphere joining all these points which are in same, having same potential, called as equipotential surface. At any point on this surface, the potential is same. The potential difference between any 2 points on this equipotential surface is 0. This is the equipotential surface for one charge. But in our problem, here there are 2 charges. If it is negative charge, the lines are towards it. If it is positive charge, the electric lines are away from it. So, as in this case, here if you draw the equipotential surface, before that let this one be the midpoint of the dipole. And if you draw the equipotential surface for this charge with radius r, the same way if you draw the equipotential surface for this charge with the same radius r. So both equipotential surface are same with same radius. So the equipotential of potential at this point due to this charge is equal to the potential at this point due to this charge. Reason radius is same, the magnitude of the charge also same. This is one equipotential surface due to the positive charge of the dipole, and this is the equipotential surface due to the negative charge of the dipole. If you draw another equipotential surface with radius r1 due to this positive charge, and similarly you can draw another equipotential surface due to this negative charge with radius r1. Here the potential at this point is same as the potential at this point. Reason r1 distance and the charge magnitude is same. If you draw another equipotential surface by keeping the midpoint as a radius, this is the equipotential surface for the positive charge of the dipole, and similarly this is the equipotential surface for this charge, negative charge of the dipole. So what results? This is on equipotential surface of the positive charge of the dipole, and this is the equipotential surface of the negative charge of the dipole. So at this point, these two equipotential surfaces crossing each other. So the net resultant is acting at this point due to the dipole. What is the electric field? What is the equipotential surface? It is perpendicular to the axis. The why? It is a sphere. For sphere, at any point, the direction could be calculated only along the tangent. So if you draw the tangent, it is perpendicular to the axis of the dipole and it is passing through the midpoint. This one is equipotential surface due to this point charge, positive charge, but not due to the dipole. This is also a equipotential surface due to this point charge, but not due to the dipole. If you combine both charges, consider both charges, then only that will be the equipotential surface of dipole. The question is, equipotential surface of an electric dipole is, say, first option, a sphere whose center coincides with the center of the dipole. They are considering this one. This is the equipotential surface. The first option, no. This is equipotential surface due to one charge, single charge, not due to the dipole. Second option, a plane surface inclined at an angle 45 degree to the axis of the dipole. No such 45 degree arises in this discussion. So second option ruled out. Third one, a plane surface passing through the center of the electric dipole. The plane surface passing through the center of the electric dipole and perpendicular to the axis of the dipole. Yes, this one must be the correct answer. So option C is correct. So for equipotential surface of an electric dipole is a plane surface passing through the center of the electric dipole and perpendicular to its axis. Next, 2. When electric slab is introduced between the plates of a charged parallel plate capacitor, its dash. What happens to potential? What happens to electric field? What happens to charge? What happens to capacitance? That is the aim of the problem. When electric slab is introduced between the plates of a charged parallel plate capacitor, that means a capacitor is charged by connecting with a battery and then it is disconnected. Meaning it is a charger. Here the battery is not continuously connected in this problem, not mentioned there. That means the battery is disconnected. Or say the capacitor is disconnected from this battery. So that means let this one be the capacitor, charged parallel plate capacitor. Say positive charge is available here, negative charge is available here. That is after disconnecting with the battery, it's a charged parallel plate capacitor. When a dielectric slab is introduced between the plates, before introducing the plates, the charge is Q. Hence the potential developed is V, so its capacitance is C is equal to Q by V. If the dielectric slab is introduced between the two plates, let this one be the dielectric available or inserted between the parallel plate capacitor, what will happen to the charge? Nothing will happen. If you insert a dielectric slab, the charge remains unchanged. No increase, no decrease in charge. Charge remains constant. And what will happen to the electric field is the electric field at a point in between the two opposite charged sheets in air is sigma by epsilon naught. We know that one. It is that is one of the applications of Gauss theorem. The electric field at a point in between the two oppositely charged sheets, sigma by epsilon naught. Otherwise, if dielectric medium is available, it is sigma by epsilon. The electric field at a point in the dielectric medium in between the two opposite charged plates is sigma by epsilon naught, can be written as sigma by epsilon naught into epsilon r. Air irundha verumane epsilon naught varudhu. Dielectric medium irundha epsilon r varudhu. For any dielectric medium other than air, its value is greater than 1. As denominator is greater, increases, the result is decreasing. So Q remains unchanged, electric field decreases. Am I right? As epsilon r is greater than 1 for any dielectric medium other than air, as denominator is more, the result is E is less, that's why electric field decreases. As electric field decreases, the potential also decreases. Reason, electric field is defined as formula minus dV by dr. Potential by distance, potential gradient. Negative gradient of potential is electric field. As electric field decreases, meaning potential decreases. Yes, when potential decreases, C is equal to Q by V formula. If V decreases without change in charge, if V decreases, capacitance increases. So, when a dielectric slab is inserted between the two charged parallel plate capacitor, the charge remains unchanged. The electric field decreases, electric potential decreases, the capacitance increases. These are the conclusions drawn. Now let us see the options available. Electric potential increases. No. We have confirmed that electric potential decreases. But electric potential increases. Option A ruled out. Option B, electric field decreases. Yes, electric field decreases. That is our explanation also. So B is correct option. Even then, let us see the third option, C, charge increases. No, initially we have mentioned that the charge remains unchanged, no change in charge. Fourth one, the capacitance decreases, no, capacitance increases. When dielectric slab is introduced between the two oppositely charged plates of the capacitor, the capacitance increases. Effect of dielectric, capacitance increases. So, second option B alone is correct. இதே கொஸ்டினை வேறு மாதிரி கேட்கலாம். When a dielectric slab is introduced between the plates of a charged parallel capacitor, the only quantity which does not change, கொஸ்டினை மாற்றிடலாம். The only quantity which does not change அப்படின்னு சொல்லிட்டு potential option, electric field option, capacitance option, energy option and charge option. இதெல்லாம் சொன்னேன். Charge alone remains unchanged, does not change. Whereas potential, electric field, capacitance, energy in this capacitor, all the four changes. Increase or decrease explain பண்ணிட்டோம். Change ஆகும். So question வேற மாதிரி கேட்டாலும் சரிதான். Answer, the charge remains same. Pass on to the next one. 3. When the charge given to a capacitor is doubled, its capacitance, when the charge given to the capacitor is doubled, what will happen to the capacitance? Say this is one capacitor. Already the capacitor is having some charge. So let it be Q. So its potential is V. We know that when charge is given to a conductor, potential is developed in the conductor. So Q is the charge, V is the potential developed, hence the capacitance is defined as the charge given to the conductor by the potential developed by the conductor. The ratio of the charge given to the conductor to the potential developed by the conductor is called capacitance. Definition of capacitance, and it is measured by the unit farad. Here the problem, when the charge given to the capacitor is doubled, what will happen to the capacitance? Again, I am mentioning that one, as Q is given to the capacitor, V is developed. As Q increases, V also increases. As Q decreases, V also decreases. The two are directly proportional. The potential developed by the conductor is directly proportional to the charge given to the conductor. So Q is proportional to V, or Q is equal to CV. That's why C is equal to Q by V. See, what is the problem? When the charge given to the conductor is doubled, if this Q is doubled, then the potential also becoming doubled. Why? The two are directly proportional. Directly proportional, charge double achina, potential double agudhu. So two cancel. Hence original result is maintained. That is, capacitance does not change. In the previous question, dielectric medium பேசணும். இந்த கொஸ்டினில் சார்ஜ் என்ன பண்ணுறேன், without changing the medium and without bringing any other material nearby the capacitor, or even without connecting the capacitor to a battery, simply in a capacitor, the given charge is doubled. What happens to the potential? Double. Reason the two are directly proportional. அது ட்வைஸ் ஆச்சுன்னா இதுவும் ட்வைஸ் ஆகுது. அப்போ 2 கேன்சல் ஆகுது. அப்போ சி ஒன்ஸ் அகெயின் Q by V. ஸோ பழைய சிஏ மெயின்டைன் ஆகுது. ஸோ கெப்பாசிட்டன்ஸ் டஸ் நாட் சேஞ்ச். தட் இஸ் த ஆப்ஷன் டி. Next, 2 point charges plus Q1 and plus Q2 are placed in air at a distance of 2 meters apart. One of the charges is moved towards the other through a distance of 1 meter. The work done is dash. Let me repeat. 2 point charges plus Q1 and plus Q2 are placed in air at a distance of 2 meters apart. One of the charges is moved towards the other through a distance of 1 meter. The work done is dash. What is the amount of work done? Yes, the problem is about potential energy. Two charges are placed at some distance. Hence, the two charges, one and another, the two charges either repelled one another or attracted towards each other. Any repulsion or attraction, they are under strain. When they are under strain, when something under strain, that something should have the potential energy. That is, a potential energy is energy possessed by the body due to by virtue of its state of strain. When something is, some body, something or some charge is under strain, that body should have the potential energy. So here also the problem is about the potential energy of the point charges. Concept, potential energy of the point charges. Say in this one, let this one be the charge Q1 and this one be the charge Q2. Positive charge ரெண்டுமே அப்போ repulsion சொல்கிறாங்க. Repulsion potential energy maximum இருக்கும். They are under maximum strain. Separated by distance of R is equal to 2 meter. Now what is the potential energy? The potential energy is epsilon I, initial potential energy. The potential energy formula, yes, you have the thorough knowledge. இப்போ தான் potential சொன்னோம். In the case of potential it is Q by 4 pi epsilon naught R multiplied by another charge. So Q1 Q2 by 4 pi epsilon naught R. This is the potential. For R it is 2 meter. Let us do the calculation finally. This is a first line. That is the explanation for the first line. One of the charges is moved towards other through a distance of 1 meter. Let us bring this charge, move this charge towards this one by 1 meter. Repeat the diagram. So this is the first charge kept at the same distance, whereas the Q2 charge is moved towards the another one. That is by a distance of 1 meter move பண்ணோம். What is the rest of the distance? It is 1 meter. இதுவும் R வேணும். இது R1, இது R2. Now the two are brought close to each other. The repulsion will be stronger. More repulsion, more strain. Potential energy அதை விட increase ஆயிருக்கும். What is the potential energy? Epsilon F is equal, final potential energy is equal to, again the formula, same two charges and the distance is varying, that is inge R2, inge R1. So initial potential energy when the two are at 2 meter distance, final potential energy when the two are at 1 meter distance. That is clear from the two lines of the problem. What is the work done கேட்குறாங்க, potential energy change in potential energy வந்துருக்குது. work done கேட்குறாங்க, a well known theorem for you, work energy theorem. As for work energy theorem, the work done is equal to, work done by the system is equal to change in kinetic energy plus change in potential energy. Here the change in kinetic energy does not arise, only change in potential energy. So as per work energy theorem, the amount of work done is equal to change in potential energy, final potential energy minus initial potential energy, that is Q1 Q2 by 4 pi epsilon naught R2 final. Q1 Q2 by 4 pi epsilon naught R1 is initial. So what is the result? W is equal to common terms எடுத்தோம்னா it is instead of R2 substitute 2 and instead of R1 substitute instead of R2 substitute 1 meter and for R1 it is 2 meter. So Q1 Q2 by 4 pi epsilon naught. இங்கே R2 is 1 meter, 1 by 1 minus 1 by R1 is 2 meter. So what is that? 1 by 1 is 1. 1 minus half? 1 minus half. So what is the result? Q1 Q2 by 1 minus half. 1 by 2 or half இருக்குது 4 pi epsilon naught. So that is equal to 2 into 4, 8. So Q1 Q2 by 8 pi epsilon naught. So the correct option answer is 1 by 2 into Q1 Q2 by 4 pi epsilon naught சொல்லலாம். Q1 1 by 2 half Q1 Q2 by 4 pi epsilon naught சொல்லலாம். Otherwise 2 4 multiply பண்ணி சொல்லலாம். Q1 Q2 by 8 pi epsilon naught. Yes, let us say the first option Q1 Q2 by 4 pi epsilon naught, no. 2 Q1 Q2 by 4 pi epsilon naught, no. Q1 Q2 by 8 pi epsilon naught, yes, option C is correct. Clear? It's a good problem. Work energy theorem. See the next, fifth question. Point charges plus Q minus Q are placed at the corners A, B, C and D respectively of a square. O is the point of intersection of the diagonals AC and BD. The resultant electric field intensity at the point O is dash. Yes, listen. The problem is about 4 point charges placed at the 4 corners of a square. Let this one be the square. A, B, C, D plus Q as per the order given in the question. Plus Q minus Q are placed at the corners A, B, C, D of the square respectively. Y is the point of intersection of the diagonals AC and BD. This is one diagonal and another diagonal. The two diagonals intersecting at this point O. The problem is about aim of the problem, resultant electric field intensity at the midpoint O. What is the resultant electric field at this midpoint O? Yes, this point is at a distance R from this point charge A at A. Squaring in the distance R, this distance also R, this one is also R, this one is also R. The side is A, you can calculate the half of the diagonal. Yes, it is not such a problem. Here only direction of the electric field. So this distance, this one all are equal. Charge is same, distance is same. Charge is same, distance, same, magnitude of charge is same, distance is same. So electric field E is also same. Due to this positive charge, here what is the electric field? Let it be E. What is its direction? Positive charge. We know the direction of electric field. If it is positive charge, away. Repeat. If it is positive charge, then at this point, electric field is Q by 4 pi epsilon naught R square. And it acts away. E vector. And due to this positive charge, point charge at this point at same distance, the electric field is E. It is acting away. இதுவும் positive charge தான் away. Same value E, same distance, same charge. And due to the negative charge here, at this point O, what is the electric field? Again the formula is same. That is E equal to Q by 4 pi epsilon naught R square. And its direction is towards. Why? It is negative charge. Since it is negative charge at this point, away towards the negative charge, it is another E vector. And due to this negative charge at this point O, what is the electric field? Again the magnitude is same, adhe formula tha, adhe value tha, but its direction towards. So பாசிட்டிவ் பாசிட்டிவ் நெகட்டிவ் நெகட்டிவ் கொடுத்ததுனால இட் இஸ் இங்க E plus E 2E இங்க E plus E 2E வந்துருக்குது. பாசிட்டிவ் சார்ஜ்னா away from that charge at that point, negative charge towards at that point, towards the charge. Now what is the resultant electric field? Yes, this is one vector, this is another vector. When two vectors are inclined by some angle theta, how to find the resultant of the two vectors? Use triangle law of vectors or parallel law of vectors or vector resolution of vectors. Vector resolution method. Here parallel law of vectors, root of p square plus q square plus 2pq cos theta. Of course, the aim of the problem is direction. So this is one vector 2e. This is another vector 2e. So complete the parallelogram. So if this is 2e, it is also 2e. If this is 2e, this is also 2e. And angle between these two vectors 90 degree, 90 degree, 90 degree, 90 degree. Why? It is a square. So angle between the two vectors 90 degree. And hence the resultant of the two is acting along the diagonal of the parallelogram. The resultant of the two sides, two vectors acting along the diagonal of the parallelogram passing through the common tail of the two vectors. So this must be the resultant electric field. So the resultant electric field intensity acts along this direction, which is parallel to BC, or which is parallel to AD, or which is perpendicular to AB. So இருக்கிற ஆப்ஷன்ஸ்ல perpendicular to AB இருக்குதா பாருங்க, இல்ல. parallel to BC இருக்குதா பாருங்க, இல்ல. Sorry, parallel to BC, yes, it is available. The second option. The first option parallel to AB இருக்குது, no. Third option C ல acts parallel to CD இருக்குது, CD க்கு parallel, no. So this is parallel to BC. Option B. Option B ல acts in the direction parallel to BC ன்னு இருக்குது. So second option is correct. So direction of electric field தெரியுதுன்னு செக் பண்ணிருக்கு. Again remember the point. The electric field at a point acts away if the charge is positive. அந்த சார்ஜ்லேருந்து away. அதுவே நெகட்டிவ் சார்ஜில் இருந்தால் அந்த பாயிண்ட்லேருந்து towards the negative charge. So in the direction of the electric field தெரிஞ்சுக்கிட்டோம்னா இதில் தப்பு வரவே வராது. இதில் மேக்னிடியூடும் கேட்டிருக்கலாம். மேக்னிடியூட் கேட்டிருந்தாங்கன்னா இப்போ நான் சொன்ன parallel vectors root of p square plus q square plus 2pq cos theta. root of p square பதிலாக 2e square, 2e the whole square, p க்கு பதிலாக அந்த q பதிலாக 2e இல்லையா, அப்போ 2e the whole square plus 2pe into 2e into 2e, root of p square பதிலாக 2e the whole square plus 2e the whole square plus 2 into pq, pq க்கு பதிலாக ஒரு 2e, q பதிலாக ஒரு 2e the whole square cos 90. Yes, angle between two vectors 90 சொன்னோம், square. அதனால இந்த angle எல்லா angle 90 since it is a square. So cos 90 is 0, 0 anything 0. அப்போ 2e தான் 4e square plus 4e square 8e square. root 8e square can be simplified as 2 root 2 into e. Suppose இதே கொஸ்டின் மேக்னிடியூட் கேட்டிருந்தாங்கன்னா ஆன்சர் இஸ் 2 root 2 into e. அதே மாதிரி இந்த சேம் கொஸ்டின் டைரக்ஷன் 4 சார்ஜஸ்ல plus q minus q பதிலா plus q நாங்க எல்லாமே பிளஸ் ன்னு சொன்னேன். அவே ஒரு e, அவே 1e பிளஸ், இதுவும் பிளஸ் தானே, அப்ப அவே 1e, இதுவும் பிளஸ் தானே, அவே 1e. அப்ப these two e's equal and opposite cancel, these two e's equal and opposite cancel. What is the resultant electric field at the center? 0. நாலுமே பாசிட்டிவா இருந்தா, நாலுமே நெகட்டிவா இருந்தா resultant is 0. But here 2 positive and 2 negative இருந்தனால resultant is acting along this direction parallel to BC or parallel to AD or perpendicular to AB, and its value is 2 root 2 into E. E is calculated using the expression Q by 4 pi epsilon naught R square. Anyhow, for this question the answer is B. Option B is correct. The unit of molecular polarizability. Molecular polarizability, it comes to the concept effect of dielectric in the capacitor. That means about the non-polar molecule and polar molecules. A non-polar molecule is a molecule in which the center of all negative charges coincide with center of all positive charges. The two centers coincides, does not. The two centers coincide, they are not separated, so non-polar, no poles. Hydrogen, nitrogen, these molecules. Hence, no dipole moment for this molecule. Polar molecule means the two centers, the center of all negative charges separated slightly by center of all positive charges. Two centers are slightly separated, having the dipole moment. Dipole, it is dipole, polar molecule. Example, water molecule, the best example, water molecule, carbon dioxide molecule. So in this dipole, or even in this non-polar molecule, you can induce. By applying the electric field, we can make the center of positive charge and center of negative charge to be separated. By applying the electric field, what is induced dipole moment. So this induced dipole moment or even a permanent dipole moment generally oriented randomly. Say for example, this is the dielectric substance. This is one dipole, say negative charge, positive charge, two equal charges, opposite charges separated by small distance. This is one dipole having the dipole moment from minus q to plus q. This is the direction of dipole moment p vector. And this is another dipole, it is negative charge, positive charge. This is another dipole, this is negative charge, positive charges. So the electric dipoles are oriented randomly. When we apply the electric field E externally, then all these dipoles, either induced dipole or permanent dipoles, aligning themselves in one particular direction. You can give the direction. All the electric dipoles are aligning in one particular direction along the direction of the applied electric field. Negative to positive, negative, positive, negative, positive. This is the dipole moment. This is the dipole moment. This is the dipole moment of this dipole. This is the dipole moment. So dipole moment is all the dipoles aligning in the same direction or along the direction of the applied electric field, what we call dielectric polarization. Electric polarization, charge polarization. During this dielectric charge polarization, the obtained dipole moment P depends on applied electric field, strength of the electric field. It is directly proportional to E. If more electric field is applied, more number of dipoles aligning in this direction. That is, P value further increases. Both are vectors. So this P is equal to some constant alpha into E, where this alpha is called molecular polarizability. That is the aim of the problem. This alpha is molecular polarizability. P equal alpha into E. Therefore, alpha is equal to P by E. What is the unit that கேட்டிருக்காங்க? Okay. The dipole moment per unit electric field is defined as molecular polarizability. For dipole moment, it is nothing but product of one of the two charges and the dipole distance, q into 2d. For charge it is coulomb, for distance it is meter. For dipole moment the unit is coulomb meter by. For electric field the unit is, electric field defined, force per unit positive charge, F by Q, Newton by Coulomb, Newton by Coulomb. So coulomb மேல போனா coulomb into coulomb, coulomb square ஆயிடும். Newton இங்க வந்தா Newton power -1, இது meter. So what is the unit of dielectricity? Molecular polarizability, this is the unit. Or even you can write in another way, Newton per coulomb பதிலா இந்த electric field volt per meter போடலாம். Electric field equal to dV by dr, negative gradient of potential. Therefore, coulomb meter by Newton per coulomb பதிலா volt by meter போடலாம். So this meter goes here, meter square. So coulomb into meter square. This volt goes numerator, volt power -1. So நமக்கு option 4 optionsல இது இருக்கலாம் இல்லைன்னா இது இருக்கலாம், ரெண்டுத்தில் எது வேணாலும் இருக்கலாம். ஏன்னா வோல்ட் பர் மீட்டரும் நியூட்டன் பர் கூலும் போத் ஆர் த யூனிட் ஆஃப் எலக்ட்ரிக் ஃபீல்ட். போத் யூனிட் கிடையாது, ஈக்குவலண்ட். த டூ ஆர் ஈக்குவலண்ட். ஸோ ஆப்ஷன் 1 கூலும் ஸ்கொயர் நியூட்டன் பவர் -1 மீட்டர். Yes, this is available the first option. Where this one is இங்கே இருக்க பார்க்கலாம்னா லாஸ்ட் ஆப்ஷனில் வோல்ட் வருது, பட் வோல்ட் பவர் -1 வரல. So ruled out. The first option is correct. Coulomb square Newton power -1 meter. Question number 7. Pass on to 7. A non-polar molecule. Just now I mentioned this non-polar molecule. A non-polar molecule is placed in an electric field. The induced dipole moment acts. And the problem answer explain பண்ணிட்டேன். Non-polar molecule is the molecule in which the center of all negative charges coincide with the center of all positive charges. The two centers are not displaced, separated. The two centers are coinciding. What is the dipole moment? The distance is 0. So dipole moment is 0, no dipole. But if you apply the electric field, the two are slightly separated. That is, induced dipole moment is possible there. Example is nitrogen, oxygen molecule. A non-polar molecule is placed in an electric field E vector. The induced dipole moment acts. Yes, the induced dipoles are induced, and these induced dipoles are acting along the direction of the electric field. So I think it is not necessary to redraw the diagram. Let us see the same diagram. Already I mentioned, in a non-polar molecule, a non-polar molecule is placed in external electric field E. The induced dipole moment acts, put negative to positive, that is dipole moment. So this P vector is acting along the direction of E vector. So the dipole moment acts in the direction, along the direction of the electric field. So from this explanation itself, you can give the answer. The induced dipole moment acts in the direction of E vector, that is electric field vector, external electric field. Option C, but the opposite to the electric field, no chance. Perpendicular electric field, no. Second rule is randomly is available when no external electric field E vector is available. So for 7th question, from question number 6 itself, the answer is drawn. The induced dipole moment acts in the direction of the external applied electric field E vector. Question number 8. A dielectric medium is placed in electric field E0. The field induced inside the medium, dielectric medium. What is dielectric medium? Insulator. A dielectric medium is placed in the electric field E0. Say these are the two plates, parallel plates. These plates are given with positive charge, negative charge. That means opposite charges. And due to this positive charge, the direction of the electric field is away. Due to the negative charge, the direction of electric field towards, negative towards it, positive away. In between the two oppositely charged. Application of Gauss theorem. So this is the electric field existing between the two plates. Let it be E0. Again repeating, a dielectric medium is placed in this electric field. In the electric field E0 தான் dielectric medium வைக்க சொல்றாங்க. So this is the dielectric medium, nothing but insulator, say mica sheet or glass or paper. The field induced inside the medium, in the mediumத்துக்குள்ள எவ்வளவு field induce ஆகும்னு கேக்குறாங்க. Yes, when dielectric medium is inserted in the electric field, the dielectric polarization takes place. What I have mentioned there, dielectric polarization takes place. So in the dielectric medium, the dipoles are there, the dipoles are aligning in one particular direction, negative charge to positive charge, meaning dipole moment is along the direction of the electric field. So negative positive, this is P vector, and similarly negative positive is P vector, negative positive P vector, negative positive, and these the dipoles are aligned, dielectric polarization takes place. The dipoles are arranging in one particular direction along the direction of the existing external electric field E naught. So this is minus to plus, negative, minus q to plus q, minus q to plus q, minus q to plus q, all are minus q to plus q in the same direction, this P vector. This already solitone. The induced dipole moment acts in the direction of the electric field in already solitone, previous question answer. But in other case, the induced field inside the medium. Now all the negative charges, induced negative charges coming to the left hand side, what we say minus qi, induced negative charges. All the positive charges are coming to the right hand side is plus qi. Induced positive charge, induced negative charge. You know what is the direction of electric field? Away if it is positive charge. Say in this medium at this point, what is the direction of electric field? If it is positive charge, away. If it is negative charge, towards. Then starting line solittu varum. So if it is positive charge, it is at a point it is acting away from the positive charge. If it is negative charge, at this point it is towards the negative charge. So this is the direction of electric field. So electric field inside the medium acts, induced electric field EI acts in this direction, positive to negative, or away from positive and towards negative, either way. Applied field E naught இப்படி இருக்கு. The field inside this dielectric medium இப்படி வந்திருக்குது EI. So அதுக்கு இது opposite. See the options. A dielectric medium is placed in the electric field E naught. The field induced inside the medium, option A, acts in the direction of the electric field E naught. E naught directionலயே இருக்குன்னு சொல்றாங்க. No, P vector தான் இருக்கும். Induced dipole moment தான் அந்த directionல இருக்கும், not electric field. Option B, induced the field induced inside the medium acts opposite to E naught. E naught க்கு opposite, so option B is correct. Acts perpendicular to E naught, no chance. Option D is 0 ஆகிறது chance இல்லை. Reason, நாம கொடுத்திருக்கிற charges, அதனால வந்து electric field E naught is stronger, but induced charges only in small amount. அப்ப induced electric field is only a small value, weak electric field. So anyhow, electric field, net electric field decreases, அதுக்காக 0 வரவே வராது, ஏன்னா these charges only in small amount. For the question number 8, the option B is correct. I think this explanation is sufficient for you. Next, the ratio of induced and inducing electric field in a dielectric medium of relative permittivity epsilon r is dash. The ratio of the induced and inducing electric field in a dielectric medium of relative permittivity or dielectric constant epsilon r is dash. Again, similar to the previous three problems. Similar to the previous three. Yes, listen. What do you mean by induced and inducing electric field? Consider the two parallel plates given with the charge, positive charge, negative charge, oppositely charged. Hence, the electric field at a point in between the two plates is positive charge away and it is negative charge towards. Let it be E naught, what we say, existing electric field, external electric field, inducing electric field. It is going to induce some other field. When a dielectric medium is inserted, I am repeating the explanation. This is a dielectric slab, dielectric sheet, whose dielectric constant or relative permittivity is epsilon r, having no dimension, no unit. When this dielectric slab is introduced in this dielectric field, this electric field is producing the dielectric polarization. That means the dipoles are aligned by this electric field in one particular direction. Yes, what is the direction? Negative charge to positive, negative to positive, minus q to plus q. That is the direction of dipole moment. So this is dipole moment. And just now I have mentioned negative charges are coming here, that is minus qi, positive charges to the right side plus qi. So once again the electric field, if it is positive charge away, if it is negative charge towards, so this is called induced electric field. Am I right? This field is inducing this field. So this is induced electric field and this is inducing electric field. The aim of the problem, the ratio of the induced and inducing electric field, meaning induced EI by E naught is equal to how much in terms of epsilon r கேக்குறாங்க. So E naught தெரியாது. Yet you know what is the resultant electric field? E vector is equal to E naught vector plus EI vector. Electric field is a vector quantity. So what is the net electric field, resultant electric field? It is a vector sum of the individual electric fields. The resultant electric field after introducing, due to the introduction of this dielectrics lab alone, is the vectorially add the two. Vectorially add the two, since E naught and EI are in opposite direction, we have to put minus. So E is equal to E naught minus EI. Therefore, bring this minus E naught to the left side, plus E naught EI இந்த பக்கம் வந்து ப்ளஸ் ஆச்சு, and E naught அங்கேயே இருக்குது, இந்த E அந்த பக்கம் போனால் minus E. So what is the induced electric field? EI, which is equal to E naught minus E. Now let us come to the problem. The aim of the problem is ratio of the induced and inducing electric field. Induced EI க்கு பதிலா என்ன பண்ணலாம்? E naught minus E by E naught. So it is equal to E naught by E naught, it is cancel 1 minus E by E naught. It is equal to 1 minus E. E is nothing but electric field, application of Gauss theorem. Sigma by is E இங்கிறது with the presence of the dielectric medium. So epsilon naught epsilon r divided by sigma by epsilon naught, only air இருக்கும்போது external electric field. இது dielectric medium வந்ததுக்கு அப்புறம் தான். So sigma by epsilon naught, sigma by epsilon cancel. What is the result? 1 minus 1 by epsilon r, or say epsilon r minus 1 by epsilon r. So in the options either this one இருக்கணும் இல்லைன்னா இது இருக்கணும், ரெண்டும் சேம். என்ன இருக்குன்னு பார்க்கலாம். The ratio of the induced and inducing electric field is option 1 epsilon r, no. Option B 1 by epsilon r, no. Option C epsilon r plus 1, no. நம்மகிட்ட minus 1 வந்திருக்கு. Option D epsilon r minus 1 the whole divided by epsilon r. Option D is correct. So வரிசையாக the 4 questions க்கு same concept is same, but questions different questions. Meaning in physics, in regarding one concept we can think number of questions. Think பண்றது தான் physics subject. எப்படி வேணாலும் questions மாற்றி கேட்கலாம், எப்படி வேணாலும் கேட்கலாம். இதுதான் physics-ஓட ஒரு interest வரது ரீசனே இதுதான். Next question number 10. The magnitude of the force acting on a charge of 2 into 10 power minus 10 coulomb placed in the uniform electric field of 10 volt per meter is dash. The magnitude of the force acting, F is a question mark, acting on a charge of 2 into 10 power minus 10 coulomb placed in the uniform electric field of 10 volt per meter. So clear ஆயிடுச்சு. எலக்ட்ரிக் ஃபீல்டு நியூட்டன் பர் கூலும் சொல்லலாம், வோல்ட் பர் மீட்டர் சொல்லலாம். நியூட்டன் பர் கூலும் கொடுத்தா அவங்களே க்ளூ கொடுத்தாமா ஆயிடும் சம்முக்கு, அதனால் அவங்க அதை கொடுக்கல. வெரி சிம்பிள். கேன் யூ டிஃபைன் எலக்ட்ரிக் ஃபீல்ட்? Electric field intensity at a point in the electric field is defined as a force experienced by unit positive charge placed at the point. Simply say electric field is defined as force experienced by unit positive charge. Electric field is defined as force experienced by unit positive charge. If Q is the charge Q, Q naught is the charge Q naught. The basic definition of electric field, how to measure the electric field, force by charge. So F is equal to, it is Q into E. So F is equal to Q is given 2 into 10 to the power minus 10 into E is 10. So 10 10 power 1, 10 power minus 10 is 10 power 1. Appo A power M into A power N, A power M plus N. F is equal to 2 into 10 to the power, come on, yes, minus 9 force unit Newton. So the answer for the problem must be 2 into 10 power minus 9 Newton. It is available in the option A. Let us pass on to the next. What must be the distance between two equal opposite point charges, say plus Q and minus Q? What must be the distance between two equal opposite charges, point charges, in a dipole kadiyadu, say plus Q and minus Q? For the electrostatic force between them to have a magnitude of 16 Newton. What must be the distance between the two point charges such that the force between the two charges is 16 Newton? Force கொடுத்து distance கேட்குறாங்க, meaning Coulomb's law தெரியுதான்னு செக் பண்ணியிருக்காங்க. Yes, you know this Coulomb's law. The electrostatic force of attraction or repulsion between the two point charges is directly proportional to product of the charges and inversely proportional to the square of the distance between them. Yes. Let this one be the charge plus Q. அவங்களே கொடுத்துருக்காங்க. This is minus Q. Then what must be the distance between the two charges? Distance எவ்வளவுன்னு தான் கேட்குறாங்க. Two equal opposite point charges சொல்லிட்டாங்க. The force between the two charges is 16 Newton கொடுத்துருக்காங்க. Yes, இப்போ நான் சொன்ன Coulomb's inverse square law directly proportional to product of the charges Q into Q. Attractive force ன்னு சொல்லிட்டேன், அதனால மைனஸ் போட வேண்டாம். If it is a vector quantity, don't involve negative sign in this formula or in some direction எடுத்துக்கலாம். And it is directly inversely proportional to square of the distance. அப்போ F is equal to a constant 1 by 4 pi epsilon naught Q square by Q into Q square by D square போட்டுக்கிட்டேன். இங்கே ஆப்ஷன் எல்லாத்துலேயுமே 4 pi epsilon naught இன்வால்வ் இல்லை, கான்ஸ்டன்ட் கேன்னு வைக்க சொல்கிறாங்க. ஸோ லெட் அஸ் ஆல்சோ கீப் தட் கான்ஸ்டன்ட் கே, கான்ஸ்டன்ட் கே, ப்ரொபோர்ஷனலி கான்ஸ்டன்ட் கே, Q square by D square. ஸோ உனக்கு D square தான் வேணும். ஸோ D square is equal K into Q square by F. So it is K into Q square by F is 16. D square is this much அப்படின்னா, listen carefully, our D is equal to square root எடுங்க on both sides. Taking the square root on both sides, root K. இது Q square root எடுத்தா Q, 16 root எடுத்தா 4. This one must be the answer for the problem. ஏன்னா நான் சம் கரெக்டாக தான் போட்டுருக்கோம் ஸ்டெப் பை ஸ்டெப்பாக. ஸோ இந்த ஆப்ஷன் இருக்கணும், இருக்குதான்னு பார்க்கலாம். ஃபர்ஸ்ட் ஒன் இஸ் 8 pi Q. சாரி, ஃபர்ஸ்ட் ஒன் இஸ் 4 into root of K into Qன்னு கொடுத்துருக்காங்க. Kவும் Qவும் ஸ்கொயர் ரூட்டுக்குள்ளே கொடுத்துருக்காங்க, ராங். B, Q by 4 into root K. Yes, Q by 4 into root K meter. Option B is correct. Option B is correct. Let us see the next. 12. The total flux over a closed surface enclosing a charge Q. Total flux means electric flux. The total electric flux enclosing a charge Q is dash கொடுத்துருக்காங்க, and flux unit they mentioned the sum itself, question itself, Newton meter square coulomb power minus 1. Is the electric flux is defined as the total number of electric lines of force crossing, passing through a given area. The total number of electric lines of force passing through a given area is defined as electric flux, simply flux. That is given by the dot product of two vectors, electric field vector and area vector. That is E vector dot ds vector. Integrating over the closed surface, E vector dot dx vector or E ds cos theta. Theta is the angle between the two vectors, electric field vector and area vector. Area vector is always perpendicular to the area. Of course, electric field in area கொடுத்திருக்கு, but நமக்கு அது இல்ல கொடுக்கல. So this formula is ruled out. Yes, Gauss. This sign is Gauss, related to the flux and charge, named as Gauss law or Gauss theorem. As per Gauss law, the total electric flux of the electric field over a closed surface is equal to 1 by epsilon naught times the net charge enclosed by the surface. The total electric flux of the electric field over a closed surface is equal to 1 by epsilon naught times the net charge enclosed by the surface. That is Q by epsilon naught. But in the question, they have mentioned that the charge is simply Q. Q க்கு வேல்யூ கொடுத்துருந்தாங்கன்னா நம்ம calculate பண்ணலாம், but Q க்கு வேல்யூ தரல, Q ன்னே சொல்லியிருக்காங்க. In terms of Q, we have to give the answer option. But epsilon naught கொடுத்துருக்கா, Q by epsilon naught இருக்குதான்னு பார்த்தா இந்த question number 12 ஆல் ஆப்ஷனில் Q by epsilon naught இல்லை. ஒரு ஆப்ஷனில் 8 pi Q இருக்குது, another option 9 and 10 power 9 Q இருக்குது, another one 36 pi 10 power 9 Q இருக்குது, another one 8.854 10 power minus 12 Q இருக்குது. Meaning epsilon நாட்டுக்கு வேல்யூ கேட்க சொல்கிறாங்க. Yes, epsilon naught value is 8.854 into 10 power minus 12, we know that one. So answer must be 5 is equal to Q by divided by 8.854 10 power minus 12 இருந்தால் கரெக்டு. ஆப்ஷன் 4ல் கரெக்ட் மாதிரி தெரியுது, பட் ஆப்ஷன் டியில் பார்த்தீங்கன்னா நியூமரேட்டரில் இருக்குது 8.854 10 power minus 12. அது டினாமினேட்டரில் இருந்திருந்தால் Q by இருந்திருந்தால் அது கரெக்டாக இருக்க முடியும். ஸோ ஆப்ஷன் டி கரெக்ட் மாதிரி தெரியுது, ஏமாந்துடக்கூடாது. இட் இஸ் ரூல்ட் அவுட். தென் வேறு வழி இல்லை. எப்சிலான் எப்படி கண்டுபிடிக்கலாம்? As we know one quantity, 1 by 4 by epsilon naught 8.854 10 power minus 12 போட்டு calculate பண்ணினேன் 9 into 10 power 9 ஒரு குவாண்டம், ஒரு குவான்டிட்டி வருது. Therefore epsilon naught is equal to, இது அங்கே போனால் அது இங்கே வரும். அப்போ 1 by 4 pi 9 into 10 to the power 9 or say 1 by 9 4s are 36 pi into 10 to the power 9. ஸோ எப்சிலான் நாட் இருக்கிற இடத்துல நீ இந்த வேல்யூ சப்ஸ்டிட் பண்ணி பார்க்கலாம், நமக்கு ஆன்சர் கிடைக்குதானே. ஸோ ஃப்ளக்ஸ் 5 இஸ் ஈக்குவல் டு Q பை எப்சிலான் நாட்டுக்கு பதிலாக இந்த வேல்யூ போடுங்க, 1 by 36 pi இன்ட்டு 9 ஆல்ரெடி எடுத்துட்டோம், 10 to the power 9. டினாமினேட்டருக்கு டினாமினேட்டர் நத்திங் பட் நியூமரேட்டர். 5 இஸ் ஈக்குவல் டு 36 pi 10 to the power 9 இன்ட்டு Q. இந்த ஆப்ஷன் தான் இருக்கலாம்னு பார்க்கலாம். இல்லைன்னா வேறு சான்ஸ் ட்ரை பண்ணுவோம். ஸோ ஹியர் இட் இஸ் ஃபர்ஸ்ட் ஆப்ஷன் 8 pi Q, நோ. செகண்ட் ஆப்ஷன் 9 into 10 power 9 Q, நோ. தேர்ட் ஆப்ஷன் C 36 pi 10 power 9 Q, yes, absolutely. Option C is correct. Meaning epsilon naught value in terms of 1 by 4 by epsilon naught calculate பண்ணி substitute பண்ண சொல்கிறாங்க. ஸோ epsilon value 8.854 10 power minus 12 டைரெக்டாக போட்டு இல்லைன்னு கொஸ்டின் ராங்னு சொல்லக்கூடாது. வேறு என்ன இருக்குதுன்னு சப்ஜெக்ட் திங்க் பண்ணணும். திங்க் பண்ணுறது தான் ஃபிசிக்ஸ் சப்ஜெக்ட். பாஸ் on to the 13. Next, 2 point charges plus Q and minus Q are placed at points A and B respectively, separated by a small distance. The electric field intensity at the midpoint O of AB. Again electric field direction தெரியுதான்னு செக் பண்ண வந்திருக்கோம். ஆல்ரெடி இந்த சம் ஸ்கொயர் சால்வ் பண்ணியிருக்கோம். 2 point charges plus Q minus Q are placed at points A and B respectively, separated by a small distance. So here is one charge, so this is plus Q and this is minus Q placed at A and B respectively. ஏவுக்கு ப்ளஸ் Q, இவிக்கு மைனஸ் Q மாற்றிடக்கூடாது, அதாவது ரெஸ்பெக்டிவ்லி. செப்பரேட்டட் பை ஸ்மால் டிஸ்டன்ஸ், சம் டிஸ்டன்ஸ் R or D. The electric field intensity at the midpoint O, let this one be the midpoint O. What is electric field கேட்குறாங்க? Let the distance R na, this is R by 2. Or if it is D ன்னு வச்சுக்கிட்டா this is D by 2, D by 2 Rன்னு வச்சுக்கிறேன், D by 2 Rன்னு வச்சுக்கிறேன், where R equal D by 2. So due to this charge here, what is the electric field magnitude? Q by 4 pi epsilon naught R square. Due to this one here, what is a, due to this charge here, what is a electric field? It is q by 4 pi epsilon naught r square. Magnitude is same, but direction is important. Due to this positive charge, here what is the electric field? Yes, it is away. This is E. Due to this negative charge, here what is the direction of electric? Towards the negative charge. Am I right? Already I mentioned this one. So due to the negative charge, the direction of the electric field is again it is towards the negative charge. Up E vector. So at this midpoint, due to this charge acting in this direction, due to this charge again acting in the same direction. So both two E's are acting in same direction. That means along AB is acting. The answer is along it is AB. So option பார்க்கலாம். It is 0 னு கொடுத்திருக்காங்க. 0 வரல. E plus E 2E வருது. What is the electric field? 2E, meaning 2 into q by 4 pi epsilon naught r square. 2E வருது. First option ruled out. Second option acts along AB. Yes, correct. Third option C acts along BA. No. அவங்க ரெஸ்பெக்டிவ்லி A and B plus Q minus Q கொடுத்துருக்காங்க. ஸோ இதுதான் வரும், AB தான் வரும், BA வராது. Acts perpendicular to AB, ruled out. So option B is correct. Pass on to the next. 14th. The ratio of electric potentials at points 10 centimeter and 20 centimeter from the center of an electric dipole along its axial line. What is a dipole? Two equal opposite charges separated by small distance. Its dipole moment is P equal to Q into 2D. ஒரு டைபோலுக்கு ஆக்சியல் லைன் இருக்குது, ஈக்குவட்டோரியல் லைன் இருக்குது. Axial line is a line passing through the two charges. The line passing through the two charges called axial line. Say this is minus Q and this is plus Q, separated with small distance 2D, and it's the midpoint of the dipole. So this line is called axial line. என்ன சொல்றாங்க அந்த ப்ராப்ளத்தில்? The ratio of the electric potential at points 10 centimeter. So in the distance 10 centimeter, and then இது 20 centimeter. So 10 centimeter distanceலையும் 20 centimeter, what is the potential? V1 இருக்கும், V2 இருக்கும். What is the ratio of this V1 and V2? Repeat பண்ணுறேன், கரெக்டான்னு பாருங்க. The ratio of electric potential at points 10 centimeter and 20 centimeter from the center of the electric dipole along its axial line. Yes, using one derivation by considering the dipole as a combination of 2 point charges, by adding the two formula, that is q by 4 pi epsilon at r1, another one q by 4 pi epsilon r2, one positive charge and one negative charge, ரெண்டு தான் ஆட் பண்ணி mathematical principles யூஸ் பண்ணி simplify பண்ணினா we get the electric potential at a point due to the dipole, electric dipole, come on, P cos theta by 4 pi epsilon naught r square. Electric potential at a point due to the electric dipole. இதுதான் வருது. Axial line சொல்லிட்டோம். ஸோ இந்த பாயிண்ட் ஆக்சியல் லைன்லேயே இருக்கிறதுனால Pங்கிற டைபோல் மொமெண்ட்டும் R வெக்டரும் டிஸ்பிளேஸ்மெண்ட் வெக்டரும் சேம் டைரெக்ஷனில் இருக்கிறதுனால நான் இங்கே R வெக்டர் சொன்னேன். காஸ் தீட்டா வந்துருக்குது. இது ஸ்கேலர், இது வெக்டர், காஸ் தீட்டா வந்துருக்குது. அப்போ இங்கே ஒரு R கேப் போட்டுட்டு யூ கேன் கிவ் திஸ் ஒன் இஸ் அ டாட் ப்ராடக்ட் ஆஃப் டூ வெக்டர்ஸ், ஸ்கேலர் ப்ராடக்ட் ஆஃப் டூ வெக்டர்ஸ். P vector cross R cap by 4 pi epsilon naught R square is V, a scalar quantity, potential. Two vectors இருந்து ஒரு ஸ்கேலர் வருது, ஸ்கேலர் ப்ராடக்ட் ஆஃப் டூ வெக்டர்ஸ். அப்போ R வெக்டரும் இருக்கார், R வெக்டரும் P வெக்டரும் சேம் டைரெக்ஷன் இருக்குது. தீட்டா இஸ் 0, cos 0 is 1. So what is the potential formula? It is V equal to this value. Therefore let us take the V1 is to V2 is equal to, write the formula twice. V1 க்கு பதிலா is P, ஒரே டைபோல் தான், 4 pi epsilon naught into ஆர் ஸ்கொயருக்கு பதிலாக 10 சென்டிமீட்டர் ஸ்கொயர். இதுவும் சென்டிமீட்டர், அதுவும் சென்டிமீட்டர். மீட்டரை மாற்றணும் அவசியம் இல்லை, மாற்றினாலும் தப்பு இல்லை. இட் இஸ் அப் டு யூ. 10 ஸ்கொயர் இஸ் அடுத்ததுக்கு அதே டைபோல் தான், அதே 4 pi epsilon, பட் டிஸ்டன்ஸ் இஸ் 20 சென்டிமீட்டர் ஸ்கொயர். ஸோ தீஸ் திங்ஸ் ஆர் கேன்சல். ரேஷியோ எடுத்தோம்னா 1/100 இஸ் 1 by இட்ஸ் 20, the whole square is 400. 20 the whole square is 400. So what will be the answer? 0 0 cut பண்ணலாமா? So 1 is to 1/4 or 4 ஆல் மல்டிப்ளை பண்ண 4 is to 1. Am I right? One distance is 10 centimeter, another one is 20 centimeter. அப்போ டினாமினேட்டரில் 10 ஸ்கொயர் வருது, ஒன்றுத்துக்கு இன்னொன்று 20 ஸ்கொயர் வருது. 20 ஸ்கொயர் இஸ் 20 into 20 400. இது 100. 1/100 is 1/400, that is 1 is 1/4, that is 4 is to 1. Option D is correct. The next one, 15th question. 3 identical charges are placed at the corners of an equilateral triangle. If the force between any two charges is F, then the net force on each charge will be. 3 identical charges are placed at the corners of an equilateral triangle. Let us draw the equilateral triangle. 3 identical charges are placed at the corners of the equilateral triangle. Let this one be the equilateral triangle. A, B, C. Identical charges are placed plus Q, plus Q, plus Q, or even minus Q, minus Q, minus Q. Identical charges placed at the corners of the equilateral triangle. If the force between any two charges is F, between any two charges is F, between any two charges, charge is same, distance also same, R, equilateral triangle. And angle is 60 degrees, 60 degrees, 60 degrees, it is an equilateral triangle. If the force between any two charges is F, then the net force on each charge will be. Let us calculate the net force on the charge A. Or even you can calculate the net force on charge B, or even on C. Let us calculate the net force on A. Coulomb's inverse square law. This is one point charge, is another point charge. Between the two charges there is electrostatic force. Positive, positive, repulsion, electrostatic force of repulsion. That is, the force is directly proportional to product of the magnitude of the charges and inversely proportional to square of the distance between them and the nature of the force. That force is acting along the line joining the two charges. This is positive, this is positive, so the two forces are repulsive force. So what is the force acting, what is the direction of the force acting on the charge Q? It is along this line. Yes, this is F. The problem is mentioned as F. The force between any two charges is F, and that force F is acting along this direction. Reason, it is a force acting between the charge at A and charge at B. The two are positive charges, equal charges. So repulsive force is acting, and that force is acting along this direction. Similarly, if you consider the charge at C and charge at A, these two also positive charges. So here also the two are repulsive. So at A only we are calculating. So the force is F. So due to this B and C, on A, a force F is acting and a force F is acting. These are the two forces acting at some angle theta. If this angle is theta, 60 degree, it is also 60 degree, vertically opposite angles. Now, these two are considered as the two vectors, as the two adjacent sides of the parallelogram. Hence, if we complete the parallelogram, the resultant will act along the diagonal passing through the common tail of the two vectors. So this is the resultant force. Angle between the two vectors 60 degree. Hence, using the parallel of vectors, the resultant force is calculated root of p square plus q square plus 2pq cos theta. If p and q are the two forces inclined to the angle theta. So the resultant force Fr is equal to, one force is F, so it is F square, another force is F, it is F square, 2 into PQ, meaning 2 into another force is F, another force is F square into cos 60 degree angle between the two. So Fr is equal to root of f square plus 2f square into cos 60 value half. So 2 cancel. What is the rest? F square plus f square plus f square. So the resultant force at A is root of 3f square. F square 3f square. Square root எடுத்தா root 2 into f square root எடுத்தா f. So the answer for the problem must be root 3 into f. And that force, resultant force is acting perpendicular to BC in this triangle. The magnitude of the force is root 3 into f. Yes, that must be the answer. And the option C. Two charges, each of value q, capital letter Q, are placed at a distance r from each other. A third charge q is placed on the line joining the two charges such that all the three are in equilibrium. Equilibrium means group of forces act, but that point or charge remains at rest. Two forces or more than two forces act பண்ணோம் ஆனால் அந்த சார்ஜ் நகராது அப்படின்னா அதுக்கு பேர் equilibrium. The charge small letter q is equal to dash. Let me repeat. Two charges, each of value q, capital letter, are placed at a distance r from each other. A third charge, small letter q, is placed on the line joining the two charges such that all three are in equilibrium. The charge, small letter q, is equal to which one? Dash கேட்டிருக்காங்க. Yes, two charges, capital Q, are separated by a small distance. Say this is one charge and this is one charge. Let this charge be plus q and q, meaning implied plus q தான். அவங்க qன்னு கொடுத்துருக்காங்க. Two charges each plus q, பாசிட்டிவ் சார்ஜ் தான். ஒன்றும் போடலைன்னா பாசிட்டிவ் சார்ஜ் தான். நெகட்டிவ்க்கு மைனஸ் கம்பல்சரி போடணும். Placed at A and B. இது நாம் கொடுத்த பொசிஷன் A, Bன்னு நாம் வச்சுக்கிட்டோம். Separated by distance R சொல்லியிருக்காங்க அவங்க. Next, a third charge, small letter q, is placed in between the two on the line joining the charges. இந்த ரெண்டுத்துக்கு in between line join பண்ணுறதுல ஏதோ ஒரு இடத்துல இந்த இடத்துல வச்சுக்கலாம். Let it be at this point. இந்த சார்ஜ் q. அந்த பொசிஷன் Cன்னு இருக்கட்டும். அவங்க சொல்லியிருக்காங்க எங்கேயோ வச்சுருக்காங்கன்னு சொல்லலை. A third charge, small letter q, be placed on the line joining the two charges in between the two. Condition சொன்னாங்கல்ல அதான் முக்கியமான. Such that all the three are in equilibrium. Two forces act but at rest. Two forces act at rest. Two forces act at rest. நகரக்கூடாது, ரெஸ்ட்டில் இருக்கணும். ஈக்குவலிபிரியம் எல்லாமே மூணுமே. First let us calculate for C. C calculate பண்ணலாம். இது பாசிட்டிவ் சார்ஜ்னு கன்ஃபார்ம் ஆகிடுச்சு. இம்ப்ளாய்டு ஒன்றும் போடலைன்னா ப்ளஸ், இதுவும் ஒன்றும் போடலைன்னா ப்ளஸ்ஸு. ஆனால் இது ப்ளஸ்ஸாக மைனஸாக சொல்லலை. ஏன்னா அது எய்ம் ஆஃப் த ப்ராப்ளம் இஸ் வாட் இஸ் க்யூன்னு கேட்டாங்க. அப்போ அது க்யூவோட வேல்யூ கண்டுபிடிக்கும் போது நீ மைனஸாக ப்ளஸ்ஸாக சொல்லி தான் ஆகணும். க்யூ தான் கண்டுபிடிக்க போகிறோம். ஸோ இது ப்ளஸ்ஸாக இருந்தால் இமேஜின் கமான், இஃப் இட் இஸ் ப்ளஸ் பிட்வீன் தீஸ் டூ சார்ஜஸ் சொல்லுங்கள். The charge A, the charge Q at A is repelled in this direction. In the direction repel ஆகுமா? Yes, good. And due to this A and B, in the Q, what happens? Repulsion. So if you consider the two forces due to the charge Q, here one force act. Due to this one, repulsion, positive repulse. அப்போ this charge plus q placed at this point A cannot be in equilibrium. Why? How? Both forces are acting in same direction. ரெண்டு force ஒரே direction act பண்ணதால இந்த charge இழுத்துக்கிட்டு தான் போகும். Two equal opposite forces வந்தால் தான் this equilibrium is possible. ரெண்டுமே சேம் டைரெக்ஷனில் வருது. இது பாசிட்டிவ் சார்ஜாக இருந்தால் ரிப்பல்சிவ் ஃபோர்ஸ் டியூ டு திஸ் சார்ஜ். இது ஆல்ரெடி பாசிட்டிவ்னு கன்ஃபார்ம் அவங்களே கொடுத்துட்டாங்க. அப்போ இந்த ரெண்டான ரிப்பல்சிவ் ஃபோர்ஸ். அதே மாதிரி பி ஆல்சோ இதனால் ரிப்பல்சிவ் ஃபோர்ஸ் இப்படி ஆக்ட் பண்ணணும், இதனால் ரிப்பல்சிவ் ஃபோர்ஸ் இப்படி ஆக்ட் பண்ணணும். ஸோ இந்த பிங்கிற சார்ஜ் இப்படி மூவ் ஆகிட்டு தான் இருக்கும். So the charge A cannot be in equilibrium, charge B cannot be in equilibrium if small letter q is positive. So small letter q must be negative. It has to be negative. If it is negative, then only possible is, listen carefully, due to this negative charge, here these two are attracting forces, here one force is acting. Here one force is acting, attractive force. This is a force acting on A due to C. Say, force acting on A due to C. The same way, this is the force between these two charges. Positive, positive, repulsive force. Solala. This is the force acting on A due to B. Now, two opposite vanducha. So, maybe equilibrium. Now, equilibrium is possible. Similarly, between these two, positive and negative, attractive force. Attractive force. That is, this is a force acting on B due to C. And due to these two forces, repulsive force. Force acting on B due to A. So, now this one is also in equilibrium, and this one is also remaining in equilibrium. Why? The two are in opposite direction. What is this force? Let me give the name. This force is force acting on C due to A, and is a force acting on C due to B. First let us take this one. Force acting on C due to A. Force acting on the charge at C due to the charge at A is equal to force acting on the charge placed at C due to the charge at B. Meaning, force between this C, place C and A, this C, the A, between these two charges. Say, Coulomb's inverse square law, Q1, Q2 by 4 pi epsilon naught R square. Yes, this is Q and it is Q, while using the negative sign only for direction only. No, don't involve the negative sign in the formula, since force is a vector like field. Q by 4 pi epsilon naught into distance between the two charges. We don't know. It is placed at some position in between A and B. Let it be x. Let it be x. This one is R minus x. Do you agree? Why? Total distance is R. Let it be x. C எங்கே வச்சுருக்கேன்? இந்த Qங்கிற சார்ஜ் Cங்கிற பிளேஸ் வச்சு எங்கே வச்சுருக்கேன்? X டிஸ்டன்ஸில் வச்சுருக்கேன். அவங்க சொல்லலை ப்ராப்ளத்தில் எதுவுமே. So it is x square. It is equal to, now come here, it is Q into Q by 4 pi epsilon naught into x square R minus x the whole square. Coulomb's inverse square la adani. So Q cancel, Q cancel, this one also cancel. X square is equal to R minus x the whole square. Taking square root on both sides. X is equal to R minus x. Minus x comes here. X plus x, 2x. 2x is equal to R. X is equal to R by 2. So, one confirm பண்ணிட்டேன். The small letter charge Q must be placed exactly at the center of the two charges. So, using this one, this Coulomb's law, this equilibrium concept, we have located the charge, third charge. We have located the position of third charge as x is equal to R by 2, exactly at the midpoint. What is the distance between Q and Q? Now it is R by 2. What is the distance between Q and Q? Now it is R by 2. What is it between A and C? R by 2. What is it between B and C? R by 2. Proved. Now it is very easy for you. This charge is in equilibrium, or this one is in equilibrium. Either this one or that one, both are similar, both are same. So let us take any one. Let us take this charge A. The force acting on the charge A due to the charge B is equal to the force acting on the charge A due to the charge C. Why? If the two are equal, then only the charge A remains in equilibrium. Or even you can take this one. இந்த ஈக்குவேஷன் எடுத்து சால்வ் பண்ணி நீங்கள் சால்வ் பண்ணலாம். யார் சால்வ் பண்ணாலும் சரி தான், ஏவுக்கு பிக்கு எது வேணாலும் சால்வ் பண்ணலாம், ரிசல்ட் மஸ்ட் பி சேம் வருதா பார்க்கலாம். அகைன் கூலோம்ஸ் இன்வெர்ஸ் ஸ்கொயர் லா. ஏவில் பியில் இருக்க சார்ஜ் சொல்லுங்கள், Q, பியில் இருக்க சார்ஜும் Q by 4 pi epsilon naught. இம்பார்ட்டண்ட்டு. ஏவுக்கும் பிக்கும் டிஸ்டன்ஸ் R ஸ்கொயர். இட் இஸ் ஈக்குவல் டு ஏவில் இருக்க சார்ஜ் Q, சியில் இருக்க சார்ஜ் ஸ்மால் லெட்டர் Q by 4 pi epsilon naught. இப்போது ஏவுக்கும் சிக்கும் டிஸ்டன்ஸு, ஏவுக்கும் சிக்கும் டிஸ்டன்ஸு ப்ரூவ் பண்ணிட்டு வந்துருக்கிறோம், R/2. ஸோ இட் இஸ் R/2 the whole square. 1Q cancel, this one cancel, so it is Q by R square is equal to small letter Q by R square by 4 no 4 goes to numerator. Am I right? Yes. What is your aim? R square cut. What is your aim? Small letter Q, so Q is equal to Q by 4. The aim of the problem is, what is the value of Q? The charge Q is equal to dash னு கொடுத்தாங்க, இந்த சார்ஜ் Q by 4 போடலாமா or minus Q by 4 போடலாமா? Yes, now say it is minus Q by 4. Why? Already in the starting point itself we have confirmed, if small letter Q is negative, then only all the three charges will be in equilibrium. So Q is value கண்டுபிடிச்சேன், Coulomb's law யூஸ் பண்ணி Q by 4. ஈக்குலிபிரியம் இருக்கணும்னா எனக்கு ஒன்று நெகட்டிவ் சார்ஜ் இருந்து ஆகணும் அந்த Q. ஸோ இட் இஸ் minus Q by 4. திஸ் ஒன் மஸ்ட் பி த ஆன்சர். ஸோ த பேசிக் லா கூலும்ஸ் லா வச்சு எக்ஸலண்ட் ப்ராப்ளம் காயின் பண்ணிருக்கோம், கூலும்ஸ் லா. And then preliminary basic concept about equilibrium. What do you mean by equilibrium? When two or more forces act at a point and the point remains in stationary or at rest, we say that one is in equilibrium. Let's pass on to the next. 17. Two charges, 40 microcoulomb and minus 20 microcoulomb. Two charges are 40 microcoulomb and minus 20 microcoulomb. One is positive, another is negative. They are at some distance apart. Let it be D. Now they are touched and kept at the same distance. The ratio of the initial to the final forces between them. The ratio of the initial force and final force between them is dash. So in this problem 17, let this one be the charge Q1, let this one be the charge Q2. This charge is 40 microcoulomb and this charge is minus 20 microcoulomb. They are placed at some distance apart, let it be D. Now they are touched, the two charges are touched together, each other. What will happen? Additive nature of charge. One of the three properties of electric charge, additive nature. The net charge of the system is algebraic sum of the individual charges. So when two bodies are brought in contact with each other, when two charges are brought in contact with each other, thereby the net charge becomes Q1 plus Q2. That is 40 microcoulomb plus of minus 20 microcoulomb, meaning 40 minus 20 is 20 microcoulomb. If the net charge is 20 microcoulomb, now the problem, now they are touched and kept at the same distance, touch பண்ணிட்டாங்க, then again the two are separated and placed at the same distance, equal distance, same distance D. Meaning when we separate these two charges again, when you separate the two charges, now the total charge 20 microcoulomb is equally divided into 2. Equally divided into 2 means 20 by 2. It is 10 microcoulomb each. So this one becomes Q3, this one becomes Q4. That is, here the charge will 10 microcoulomb, here it is 10 microcoulomb. So distance is same. And here what is the force and here what is the force? They are asking the force, initial force, ratio of the initial force to the final force. In the case of initial force, F1 is equal to a constant K, that is 1 by 4 pi epsilon naught Q1 Q2 by R square D square, distance square. where F2 is equal to, a constant again same 1 by 4 pi epsilon naught, value you know, 9 and 10 power 9, Q3 Q4 by 4 by, that is d square, again the same distance, d square. You find the ratio F1 by F2, F1 by F2, right? K cancel, d square cancel. So it is equal to Q1 Q2 by Q3 Q4. Q1 Q2 is 40 microcoulomb into Q2 is 20 microcoulomb. While calculating the magnitude, negative sign not necessary. Negative sign is only for attractive force. It is useful only in additive nature of charge. Divided by Q3 and Q4, 10 microcoulomb and 10 microcoulomb. Micro cancel, 10 power minus 6, 10 power minus 6. 10 power minus 6, 10 power minus 6 cancel. 0 cancel, 0 cancel. So it is 8 by 1 or 8:1 must be the answer for this problem. So here the additive nature of charge, that property has been tested. And when we separate the two charges which are in contact, the charge is equally divided, and by using Coulomb's inverse square law, it is possible to calculate the ratio of the two forces. The answer is 8:1. It is in the option B. An electric dipole with a dipole moment of magnitude P. Electric dipole having dipole moment, one of the two charges into dipole distance, P equal Q into 2D. That's சொல்றாங்க. An electric dipole with a dipole moment of magnitude P is in stable equilibrium in an electric field of magnitude E. The work done in rotating this dipole to its position of unstable equilibrium is, repeat, an electric dipole with a electric dipole moment of magnitude P is in stable equilibrium in the electric field of magnitude E. Electric dipole is stable in the electric field சொல்றாங்க. Stable equilibriumத்தில் இருக்குதுன்னு சொல்ல, stable equilibrium சொன்னாலே, as a physics student, as a physics persons, we must know the potential energy is minimum. A body or particle or system or anything possess minimum potential energy, it will be stable. Maximum potential energy unstable. So stable equilibrium னு சொன்னாலே potential energy is minimum. Unstable equilibrium னு சொன்னாலே it is potential energy maximum. So an electric dipole of dipole moment of magnitude P is in stable equilibrium. அப்போ மினிமம் பொட்டென்ஷியல் எனர்ஜி அப்படின்னு சொன்னால் ரெஸ்ட்டில் இருக்குது. ஸோ லெட் திஸ் ஒன் பி த எலக்ட்ரிக் ஃபீல்டு இ கொடுத்துருக்காங்க. அண்ட் டைபோல் மொமெண்ட் ஆஃப் மேக்னெட் பி இஸ் இன் ஸ்டேபிள் ஈக்குலிபிரியம். அந்த டைபோல் மொமெண்ட் பி எப்படி இருக்குதுங்கிறத நான் மென்ஷன் பண்ண முடியும்னு அதுக்கு தான் க்ளூ கொடுக்குறாங்க. ஸ்டேபிள் ஈக்குலிபிரியம். ஸ்டேபிள் ஈக்குலிபிரியம்னா மினிமம் பொட்டென்ஷியல் எனர்ஜி. மினிமம் பொட்டென்ஷியல் எனர்ஜின்னு சொன்னேன். கேன் யூ ரீகால் த potential energy of the dipole in the electric field? Yes, amount of work done in rotating the dipole through small angle, tau into d theta, tau பதிலா P sin theta. So P sin theta into d theta integrate பண்ண sin theta integrate பண்ண minus cos theta. So minus P cos theta, very good. Minus P cos theta is the potential energy of the dipole placed in the electric field. அப்போ எனக்கு இது மினிமம் வரணும்னா மைனஸ் பி தான் மினிமம் பாசிபிள். அப்போ எனக்கு காஸ் தீட்டா மஸ்ட் பி 1. காஸ் தீட்டா 1 மீன் தீட்டா மஸ்ட் பி 0. அப்போ தீட்டா 0ன்னு சொன்னேன், ஸ்டேபிள் ஈக்குலிபிரியம்னு சொன்னேன். அப்போ டைப்போலை இப்படி வை, தட்ஸ் ஆல். This is electric field vector, dipole vector. What is the angle between the two? Since the two are in same direction, initially the potential energy is minus Pe into cos 0. Why? Theta is 0 in this case. எப்படி 0ன்னு கண்டுபிடிச்சேன்? ஸ்டேபிள் ஈக்குலிபிரியம்னு சொன்னாங்க. ஸ்டேபிள் ஈக்குலிபிரியம் என்ன அர்த்தம்? பொட்டென்ஷியல் எனர்ஜி இஸ் மினிமம்னு அர்த்தம். பொட்டென்ஷியல் எனர்ஜி மினிமம்னு சொன்னேன், cos theta must be 1. Epsilon must be minus Pe, then only it is minimum. அப்போ theta must be 0. theta 0 வரணும்னு சொன்னேன். The two must be parallel, stable equilibrium. Cos 0 is 1. So epsilon I is equal minus PE. இப்போ second line. The work done in rotating the, what is the work done? In rotating the dipole rotate பண்ண சொல்கிறாங்க, to its position of unstable equilibrium. Unstable equilibrium இதை ரொட்டேட் பண்ணணும். இப்போ அன்ஸ்டேபிள் ஈக்குலிபிரியத்துக்கு ரொட்டேட் பண்ணணும். அன்ஸ்டேபிள் ஈக்குலிபிரியம்னு மேக்ஸிமம் பொட்டென்ஷியல் எனர்ஜி, மேக்ஸிமம் பொட்டென்ஷியல் எனர்ஜி பிகம்ஸ் அன்ஸ்டேபிள். அப்போ நீ இந்த டைப்போல் எப்படி இருக்கிற டைப்போல் இப்படி திருப்பி போட்டிங்கன்னா, இப்படி இருக்கிற டைப்போல் இப்படி திருப்பிட்டோம்னா போதும், இட் பிகம்ஸ் அன்ஸ்டேபிள். இப்போ பொட்டென்ஷியல் எனர்ஜி இஸ் மேக்ஸிமம். எப்போது தீட்டா இஸ் 180, theta 180 வந்தால் cos 180 minus 1, minus 2 minus plus. அப்போ plus P is maximum potential energy, unstable equilibrium. Yes, this is electric field vector and this is dipole moment vector. Now the two are opposite direction. Theta is 180 degree. So cos 180 is minus 1. So epsilon final is equal to minus PE cos theta க்கு பதிலா cos 180. Cos 180 is minus 1, minus minus plus. So epsilon F is equal plus PE. Yes, or 2 or 3 questions back, work energy theorem பேசணும். Potential energy change ஆகிருக்குது. Initial potential energy, final potential energy, what is the work done கேட்குறாங்க. Automatically as a physics person we have to go for work energy theorem. As for work energy theorem, work done is equal change in potential energy, final potential energy minus initial potential energy. So final potential energy is plus PE, initial potential energy is minus PE, therefore minus and minus plus. So work done is equal to இது ஒரு plus, plus PE plus plus E plus 2PE. So answer for the problem is plus 2PE. Initially stable இருக்குது, அது unstable மாற்றுறதுக்கு how much work is done அப்படின்னா it is 2PE as per work energy theorem. Like this you can ask any number of questions. It is in unstable, it is in stable equilibrium with the initial potential energy. If you want to rotate the dipole to perpendicular to the electric field கேட்கலாம். அன்ஸ்டேபிள்னா 180 டிகிரி திருப்புறோம், அதுக்கு பதில் அவங்களே பர்பண்டிகுலராக வைக்கணும், 90 டிகிரி ஆங்கிள் ரொட்டேட் பண்ணுறது ஹவு மச். அப்போ இங்கே 90 டிகிரி போடுங்க, cos 90 is 0, அப்போ இந்த ரிசல்ட் 0. அப்போ 0 மைனஸ் ஆஃப் மைனஸ் பி ப்ளஸ் பி, ஆன்சர் இஸ் ப்ளஸ் பி. ஸோ இதே கொஸ்டினை எத்தனை விதமாக மாற்றி கேட்கலாம். பட் நமக்கு பேசிக் கான்செப்ட் எலக்ட்ரிக் ஃபீல்டும் டைப்போலும் சேம் டைரெக்ஷனில் இருந்தால் தீட்டா இஸ் 0. We say the dipole is in stable equilibrium, potential energy is minimum minus PE cos theta. அதே டைப்போல் ஆப்போசிட் டைரெக்ஷன் எலக்ட்ரிக் ஃபீல்டு இருந்தால் இட் இஸ் அன்ஸ்டேபிள் ஈக்குலிபிரியம். இந்த கான்செப்ட் தான் மைக்ரோவேவ் அவனில் யூஸ் ஆகுது, நம்ம சொல்லியிருக்கோம், படிச்சிருக்கிறோம். எஸ், லெட் அஸ் பாஸ் ஆன் டு த நெக்ஸ்ட் கொஸ்டின். ஆப்ஷன் பி இஸ் கரெக்ட், ப்ளஸ் 2PE. ஸோ PE வர மாதிரி ஒரு கொஸ்டின் ஃப்ரேம் பண்ணலாம், மைனஸ் PE வர மாதிரி ஃப்ரேம் பண்ணலாம், 0 வர மாதிரி பண்ணலாம். 4 டிஃப்ரெண்ட் வேஸ் கொஸ்டின்ஸ் மாற்றலாம். பொசிஷன் ஆஃப் டைப்போலை எலக்ட்ரிக் ஃபீல்டுக்கு மாற்றுறது தான். Question number 19. Two charges of magnitude plus 4q and minus q are located at points A and 0 and 3 minus 3a and 0. So coordinates of points given. Points locate பண்றாங்க respectively. The electric flux due to these charges through a sphere of radius 2a with its center at the origin is dash. Charge fluxங்கறாங்க, again மறந்துடாதீங்க, Gauss law, Gauss theorem. The total electric flux of the electric field over a closed surface, முக்கியமான வார்த்தை, closed surface, is equal to 1 by epsilon naught times the net charge enclosed by the surface. I am stressing that point, enclosed by the surface. இந்த ப்ராப்ளத்தில் அதுதான் இம்பார்ட்டன்ட். Two charges magnitude plus 4q and minus q are located at points a, 0, x coordinate, y coordinate தராங்க. So let better draw the Let this one be the x-axis, this one be the y-axis. Two charges plus 4q and minus q are located at points A and Z, A and 0. Say this point is, this is one position where the first charge is placed, plus 4q, whose coordinates A and 0, y coordinate 0. X coordinate A கொடுத்துருக்காங்க. And minus 3a னா இது plus positive axis, இது negative x axis. Minus 3a அப்படின்னா இது minus 1a, minus 2a, இது minus 3a. Minus 3a, 0. Coordinates கொடுக்குறாங்க. That is x axis, y axis. Clear? அங்கே plus 4q வச்சுருக்காங்க, இங்கே minus q வச்சுருக்காங்க respectively. சொல்லியிருக்காங்க. The electric flux due to these charges through a sphere of radius 2a. Now we have to draw the sphere. அந்த ஸ்பியருக்கு ரேடியஸ் எவ்வளோன்னா 2a சொல்கிறாங்க. அந்த ஸ்பியர் வழியாக எத்தனை ஃப்ளக்ஸ் போகும், how much flux is passing through the sphere கேட்குறாங்க. ஸோ ஃப்ளக்ஸுக்கும் சார்ஜுக்கு ரிலேஷன் சொன்ன ஒரு காஸ் தான் திரும்பவும் சொல்கிறேன். Total flux of the electric field over a closed surface is equal to 1 by epsilon naught times a net charge enclosed by the surface. மறந்துட வேணாம், அந்த வார்த்தை தான் முக்கியமானது. Enclosed by the surface. So having 2a as the radius, இது 1a வா, அப்போ இது 2a, இது 3a, இங்கே 2a போட்டுரும். ஸோ இந்த இது 2a, இதுவும் 2a, minus 2a, இது டயாமீட்டர், அப்போ இது ரேடியஸை வச்சு now let us draw one sphere. ஸோ இந்த ஸ்பியர் வழியாக how much flux is passing? Yes, இந்த ஸ்பியருக்குள்ளே இருக்க சார்ஜ் எவ்வளவே 4q. முடிஞ்சு போச்சு. நான் அந்த ஸ்டேட்மெண்ட்டை 2 முறை சொன்னேன். ஸோ வாட் இஸ் அ ஃப்ளக்ஸு? q by epsilon naught. நான் சொன்ன ஸ்டேட்மெண்ட்டுக்கு மேத்தமெட்டிக்கல் ஃபார்முலா காஸ் சொன்னது q by epsilon naught. வாட் இஸ் த சார்ஜ் இன் அவர் ப்ராப்ளம்? 4q. 4q by epsilon naught is the answer for the problem. அப்போ இந்த மைனஸ் q எங்கே போச்சு? காஸ் லாவோட அவுட்கம் சொல்லுவார். காஸ் சொல்லுவார், சார்ஜஸ் ரெசைடிங் அவுட் சைட் த காசியன் ஸ்பியர் வில் நாட் கான்ட்ரிபியூட் எனி ஃப்ளக்ஸ். அந்த ஸ்பியருக்கு காசியன் சர்ஃபேஸுக்கு வெளியில் இருக்க சார்ஜஸ் இருந்தால் இந்த ஸ்பியருக்கு இந்த சார்ஜோட ஃப்ளக்ஸ் அக்கௌண்ட்டில் வராது. charges residing outside the surface, outside the sphere will not contribute any flux. அப்போது இந்த ஸ்பியருக்கு வெளியில் இந்த சார்ஜ் இருந்தால this will not come into account. அதே மாதிரி இன்னொன்று சொல்லுவார், this flux depends only on the net charge enclosed by the surface. Net charge enclosed by the surface. இந்த சர்ஃபேஸுக்குள்ளே என்ன சார்ஜ் இருக்குது? 4q. நீ இந்த மைனஸ் q இந்த சர்ஃபேஸுக்கு உள்ளே இருந்திருந்தா ப்ளஸ் 4q மைனஸ் q 3q தான் ரிசல்ட் கொடுத்துருப்பேன். ஏன்னா நெட்டு சார்ஜுன்னு அதான் மீனிங், டோட்டல் அல்ஜிப்ரிக் சம். அடுத்து இன்னொரு மைனஸ் சொன்னார் அவர், அந்த 4qங்கிற சார்ஜு சென்டரில் இருக்கணுமா? அப்படிலாம் ஒன்றும் சொல்லலை. இட் இஸ் இண்டிபெண்ட் ஆஃப் லொக்கேஷன் ஆஃப் சார்ஜ். சார்ஜ் லாவிலேருந்து காஸ் லாவிலேருந்து 3 அவுட்கம்ஸ் நம்ம ட்ரா பண்ணுவோம். த ஃப்ளக்ஸ் இஸ் that is the flux of the surface does not depend upon the charge residing outside the sphere, or say the charges residing outside will not contribute any flux to this body. Second one, the flux is due to the net charge enclosed by the surface. அடுத்தது the charges, the flux is independent of location of charge. Independent of plus 4q இங்கே இருக்கலாமா, இங்கே இருக்கலாமா, இங்கே இருக்கலாமா, அந்த சர்ஃபேஸ் உள்ளே இருக்கணும், அவ்வளோதான், எங்கே வேணாலும் இருக்கலாம். இட்ஸ் அ குட் ப்ராப்ளம். காஸ் லாவை திரும்ப ஒரு முறை நாம் ரீவிசிட் பண்ணுறது சான்ஸ் கிடைச்சிது. 3 identical capacitors C1, C2 and C3 of capacitance 6 microfarad each are connected to a 12 volt battery as shown in the diagram. The equivalent capacitance of the combination and the charge delivered by the battery respectively, two aims in the problem. 3 identical capacitors C1, C2 and C3, the capacitance of each one is 6 microfarad, are connected to a 12 volt battery as shown in the diagram. find the equivalent capacitance of the combination and also what is the charge delivered by the battery. Yes, it is which one is parallel, which one is series connection, that is a problem. Say C1, C2, C3, C1 is equal to C2 equal to C3 is equal to 6 microfarad and the 12 volt battery voltage EMF of the battery. Yes, since this is higher potential, positive potential, lower potential. When higher potential is given to both C3 and C1, what is the meaning? Potential is same. This plate of C3, this plate of C1 connected to positive terminal of the battery, meaning the potential same, positive potential. Similarly, negative potential is same, lower potential. That means C1 and C3 are in parallel connection. Same potential in a parallel connection. Different potential difference in the series connection. You know very well. Or in other words, say this positive potential is delivering positive charges. These positive charges are split into two parts. Depends on its capacity. Say few charges are going there. Depends on its capacity, few charges going there. But fortunately here both of them same capacity. 6 கொடுத்துட்டாங்க. But different capacity இருந்தால் அப்போ different charge தான் போகும். அப்போ different charges போகுதுன்னு சொன்னாலே that is the two are said to be in parallel connection. Again, charge differs, potential same, called charge differs, potential parallel connection. Whereas if positive charge is given here, inducing equal amount of negative charge, electrostatic induction, and this will induce equal amount of positive charge here, inducing equal amount of negative charge. So charge is same in C1, C2. So confirmed C1 and C2 are in series combination. And this combination is parallel with C3. நான் இது மட்டும் வச்சு கம்பேர் பண்ணி சொன்ன முதல்ல ஆக்சுவலாக இங்கே C1ஓட C2 சீரீஸில் இருக்குது. இந்த ரெண்டு சீரீஸ் காம்பினேஷன் அதுக்கு பேரலில் இருக்குது. இது டவுட் வராதுன்னு நினைக்கிறேன். இதுதான் இதில் இம்பார்ட்டண்ட்டே. அதுக்கு தான் உங்களுக்கு திரும்ப சொல்கிறேன். This is the higher potential connected to these two plates. அப்போ ரெண்டு பிளேட்டுமே பொட்டென்ஷியல் சேம், ஹையர் பொட்டென்ஷியல் சே ப்ளஸ் 5 வோல்ட். அதே மாதிரி இஸ் லோயர் பொட்டென்ஷியல் சே -1 வோல்ட் கனெக்டட் தீஸ் டூ பிளேட்ஸ். அங்கே எங்கேயும் மைனஸ், இங்கேயும் மைனஸ். வாட் ஹேப்பன்ஸ்? therefore இங்கே ஹையர் பொட்டென்ஷியல், இங்கே ஹையர் பொட்டென்ஷியல், பொட்டென்ஷியல் இஸ் சேம்னு சொன்னாலே தட் இஸ் த பேரலல் காம்பினேஷன். அதே மாதிரி இங்கே நெகட்டிவ் சேம்னு சொல்கிறேன். அப்போ பேரலல் காம்பினேஷன். அப்போ இந்த காம்பினேஷன் சே திஸ் இஸ் இன் தீஸ் டூ ஆர் இன் சீரீஸ் அண்ட் தட் சீரீஸ் காம்பினேஷன் இஸ் parallel with C3. So in series combination the formula for effective capacitance is 1 by Cs is equal to 1 by C1 plus 1 by C2. 1 by 6 micro plus 1 by 6 micro, 2 by 6 micro. So Cs is equal to 6 by 2 which is 3 microfarad. Now say this Cs is in parallel with C3. Cs is parallel with C3. Therefore Cp is equal to Cs plus C3. So Cp is nothing but C, net capacitance. Cs is 3 and C3 is already 6, it is 9 microfarad. So what is effective capacitance? Equivalent capacitance the combination கேட்டாங்க first question. 9 microfarad answer வந்துருச்சு. Now it is very easy. C is equal to Q by V. And what is the charge delivered by the battery? It is C into V. Net capacitance 9 micro into V is 12 volt. So it is equal to 9 2s are 18. 108 micro இருக்குது coulomb. Finished? So what is the equivalent capacitance of the combination? 9 microfarad. And what is the charge delivered by the battery? 108 microcoulomb. Or even இதே கொஸ்டினில் வாட் இஸ் த சார்ஜ் இந்த கெப்பாசிட்டி C3ன்னு கேட்கலாம், ஸ்பில் பண்ணி கேட்கலாம். எஸ் பொட்டென்ஷியல் தெரிஞ்சால் கெப்பாசிட்டன்ஸ் தெரிஞ்சால் இட் இஸ் பாசிபிள், வெரி ஈஸி. ஸோ ஃபார் திஸ் ப்ராப்ளம் 20 ஆன்சர் இஸ் D. ஆப்ஷன் இஸ் D, 9 microfarad and 108 microcoulomb. For question number 21, A and B are two hollow metal spheres. A and B are two hollow metal spheres of radii 50 cm and 1 meter carrying charges 0.6 microcoulomb and 0.1 microcoulomb respectively. 50 centimeter sphere radius இருக்கிற ஸ்பியருக்கு 0.6 microcoulomb, 1 meter radius இருக்கிறதுக்கு 1 microcoulomb. ரிப்பீட் பண்ணுறேன். A and B are two hollow metal spheres of radii 50 centimeter and 1 meter. ஸோ இது ஒரு ஸ்பியர் 50 centimeter radius, அது 1 meter radius, அப்போ அதோட டபுள். அப்போ இது ஸ்பியர் A, இது ஸ்பியர் B. A and B hollow, carrying charges Q1 is equal to 0.6 microcoulomb, Q2 is equal to 1 microcoulomb respectively. அதான் முக்கியமானது. ஏக்கு A, Bக்கு B. They are connected externally by a conducting wire. When these two spheres are like this and then they are connected externally by a conducting wire, now the charges will flow from A to B, B to A, and for what purpose it is flowing. Very simple. What is its potential? The potential of the first sphere is V1 is equal to Q1 by 4 pi epsilon naught R1. Distance, radius R1 is 50 centimeter. Meter matna 0.5 meter. And V2 is equal to Q2 by 4 pi epsilon naught into R2. R2 is 1 meter. 1 meter. So now two different charges, two different radii, two different potentials. Anyhow, ரெண்டு செப்பரேட்டாக இருக்குது. Small sphere, larger sphere. So the potential differs when we connect these two externally. அதான் ப்ராப்ளமே. They are connected externally by a conducting wire. So conducting wire வச்சு கனெக்ட் பண்ணிட்டா, now the charges will flow from A to B, B to A. How can I calculate? ஒரே ஒரு clue. When we connect the two spheres externally by this conducting wire, the potential become equal. V1 is equal to, so நாம் ஜாயின் பண்ண உடனே conducting wire வச்சு ஜாயின் பண்ண உடனே the charges will flow from one sphere to another sphere. எதுக்காக? To make the potentials same, like the flow of air from higher pressure to lower pressure to equalize, like the flow of water from higher altitude to lower altitude, higher altitude to lower altitude to equalize the level of water. Same way energy flow, potential flow. So the two potentials becoming equal. For that purpose the charge will flow from A to B or even B to A. We don't know. Let us do the calculation. Potential equal ஆகிறதுக்காக தான் சார்ஜ் ஃப்ளோ ஆகணும். அப்போ இந்த ரெண்டு ஃபார்முலா ஈக்குவேட் பண்ணலாம். Q1க்கு பதிலாக சப்ஸ்டிட் பண்ணிடலாம். 0.6 micro by 4 pi epsilon naught into R1 is 0.5 meter. It is equal to Q2 is 1 micro by 4 pi epsilon naught into 1 meter. So micro cancel. 10 power minus 6 numerical value. These two cancel. So 0.6 by 0.5 can be written as 6 by 5 எழுதலாம். It is equal to 1. 6 by 5 now it is 1.2. It is equal to 1. 1.2 is equal to 1. No. Two different potentials இருக்குது. Now when the conducting wire is there between the two, when you connect the two using the conducting wire, now the charges will flow from one sphere to another sphere. எதுக்கு? To make the potentials equal. அப்படின்னா இங்கேருந்து இங்கே வர முடியாது, இங்கேருந்து தான் இங்கே போகணும். இங்கேருந்து ஒரு 0.1 அங்கே போனால் 1.1 is equal to 1.1. தெரிஞ்சு போச்சு. So the charges should flow from A to B such that the potentials becoming equal. இருக்கா பார்க்கலாம்? Yes. Now the charges flow. அவங்களே கொடுத்துட்டாங்க. Charge flow ஆகும். So the charges flow from option A to B till the charges become equal. No, energy become equal. Higher charges to lower charges போகணும்னு அவசியம் இல்லை. Potential become equal. So option B, A to B till the potentials become equal. Option B is correct.